bright future. Every student matters.
Hello students, we're going to continue our chapter Understanding Quadrilaterals. So the topic for today is kinds of quadrilaterals. So what was a quadrilateral? A quadrilateral is a polygon having four sides. That is known as quadrilateral. Now there are different types in quadrilaterals too. So that we are going to study today. This is the main concept for today's class. Let us start with the first kind of quadrilateral, that is a trapezium. So obviously it is a kind of quadrilateral, so it will have four sides, right? Let us see the definition. It says trapezium is a quadrilateral with pair of parallel sides. With a pair of parallel sides, that means we'll just have out of the four sides, two of its sides as parallel sides. Which will be those two sides? Just see this figure here. This arrow mark like this, as it is drawn on these two sides, shows the parallelism between these two lines. If I name it as A, B, C and D. So we say that AB is parallel to, this is the symbol for parallel to DC. So AB is parallel to DC. Here we see that it is a four-sided figure, a closed figure, or I say four-sided polygon. That means it is a quadrilateral, right? And having one pair of parallel sides. So it is known as a trapezium. Figures like this are called as trapezium. Clear? So this is the first type of quadrilateral that I am going to discuss in the class. So like this, they can give you something like, I am drawing here 1, 2, 3, and suppose you have sides like this. And they have given you this and this side as parallel. So will this be a trapezium? Just think carefully. A trapezium is a four-sided polygon and it is having 5 sides. So it will not be a trapezium. Yes, it satisfies the property that it has one pair of parallel lines, but it is not a quadrilateral. It is a pentagon having 5 sides. So just not looking on one property that it has one pair of parallel lines, we need to take into consideration two things. One is a pair of parallel lines, another it should be a quadrilateral only. That means a polygon with 4 sides. Clear? Let us move to the next one, and the next one is a kite. You all might have seen kites. Just to see here, kite is a special kind of quadrilateral. What kind of speciality does it have? So I am going to show you some figures where you will see what is that special type or what is that special quality in a kite that is a quadrilateral only. That means it will also be a polygon having 4 sides. The speciality is that you can see here in these figures. So we see that the side AB is equal to side AD. So for the first figure, if I write, I'll write AB is equal to AD. Right. The second thing that we notice here is BC is given equal to DC. So we write BC is equal to DC. So what we observe here? We observe that the pair of adjacent sides are equal in kite. So it is a special quadrilateral, it is a special four-sided polygon that have the adjacent sides as equal. Pair of adjacent sides as equal, AB and AD from the same vertex A, right? They are equal to each other. Similarly, BC and DC are equal to each other. Similar property can be observed in figure 2nd and in figure 3rd. Here also the two adjacent sides or a pair of adjacent sides is equal, this one, and the second pair is also equal. So this is known as a kite. This is a special type of quadrilateral. So what we have done? We have discussed trapezium, right, which is a quadrilateral with a pair of parallel sides. And we have discussed a kite, right. Let us now go to the next type, which is the most important topic for today's class, parallelograms. It has a number of properties with it, right. Let us start with parallelogram. and it is the base of other quadrilaterals. So it is important to understand parallelogram in a much easier way. Let us start with parallelogram. What is a parallelogram? As the name suggests, as you can see, the name is parallelogram. It has something to do with parallel lines, right? So let us just see the definition of it. It says a parallelogram is a quadrilateral. So your parallelogram will be a quadrilateral. As the name suggests, it has something to do with parallel lines. So definitely in a parallelogram we'll find four sides. As it is a quadrilateral, it will be a closed figure, a polygon having four sides, and it will be something relating to parallel lines. So let us see one of the figures of it. Just to see this figure, ABCD here is a parallelogram, and it is shown that AB is parallel to DC. That means this side is parallel to this side, and AD, this side, is parallel to this side BC. Right? That means we see that what is the property of parallelogram? That the pair of opposite sides are parallel to each other. Right? The sides opposite to each other are parallel. Just to see, AB is opposite to DC and vice versa, and they're parallel to each other. Similarly, AD is parallel to BC. They're opposite to each other. So what is a parallelogram? A parallelogram is a quadrilateral having opposite sides as parallel. Clear? Now what we are going to do is we're going to discuss some basic properties of parallelogram. That what about its opposite angles? What about its opposite sides? What about its adjacent side and adjacent angles, and so on? What about its diagonals, like this? So let us first discuss elements of parallelogram. Let's start with the topic. Elements of a parallelogram. What are the elements of a parallelogram? Elements means parts only. Elements means parts only. So let us see. I'm drawing a parallelogram here. Let the parallelogram be A, B, C and D. Clear? Now what we are going to do is, I am going to define different parts. So it has four sides, right? Then it has four angles as seen. Just to see, the four sides are AB, BC, CD and DA. What about the angles? Angle A, angle B, angle C and angle D. These are the four angles. Now we say that opposite sides. Okay, what are opposite sides? Opposite sides, we can take example like AB is opposite to DC, and vice versa. We can say the same thing, DC is opposite to AB. Similarly, we can say that AD is opposite to BC, or we say BC is opposite to AD. Then comes adjacent side. What about adjacent sides? Adjacent sides are like, if I talk of AB with the same vertex A, right? AB is starting with A, and from B we have another side, that is BC. So AB and BC are adjacent sides. That means the second side is starting from the final point or the ending point of the first side. Clear? Similarly, we say that BC is adjacent to CD and so on. Clear? Then comes opposite angles. Angles opposite to each other. So we see that angle A and angle C, these two angles are opposite to each other, and angle B is opposite to angle D, like this. Clear? So these are known as pairs of opposite angles. Clear? Next comes adjacent sides. We have discussed. Next is adjacent angles. What about adjacent angles? They are lying on the same line. Like on AB we have angle A and angle B. Then we have angle B and angle C as adjacents. Then we have angle C and angle D as adjacent, and we have angle D and angle A as adjacent. They're lying on the same line. Clear? So these are our adjacent angles. So what we have discussed, the four sides, the four angles, opposite sides, opposite angles, adjacent angles. And the main property, what is a parallelogram? Having opposite pairs as parallel. That means AB is parallel to DC and AD is parallel to BC, like this. Clear? So what we have done, we have discussed what is a parallelogram. That is a quadrilateral having four sides. Obviously it's a quadrilateral, it will be a polygon of four sides, and then the basic property, the most important property is that the opposite sides are parallel to each other. Clear? Let us move to the next one now. Let us discuss the very first property of the parallelogram. It says the opposite sides of a parallelogram are of equal length. So how we are going to prove it? Let us first draw a parallelogram. So as we have learnt, a parallelogram is a quadrilateral and the opposite sides are parallel to each other. So this is a parallelogram. Let us name it as A, B, C, D. And the side DC is parallel to this side AB, and side AD is parallel to side BC. Clear? Now what we are going to do is, to prove that the opposite sides are equal, we'll draw one diagonal. Let the diagonal be AC. Let us join A to point C. So AC is our diagonal. Now this diagonal divides this parallelogram into two triangles. Triangle ABC and triangle ADC. So let us write triangle ABC and triangle ADC. What do we observe in these two triangles? So first of all, I am marking the angles. I am marking the angles as 1, 2, this one be 3 and this one be 4. Right. Now we see that AC is common in these both triangles. So we will write that AC equals AC because this is the common side in these two triangles. Next thing is, we see that angle 1 will be equal to angle 3. What is the reason that angle 1 is equal to angle 3? Think of it carefully. The side AB and side DC, they are parallel to each other. So it is like this. I am drawing it out separately. Let this be DC, okay, and let this be AB. So these two are parallel to each other, one thing. Then we have joined A to C, right? So these are the two parallel sides and AC here is our transversal. So because of this angle 1 that we have drawn here, this is our angle 1, right? We have drawn this angle 2 and named this angle as 3 and named this angle as 4. So definitely angle 1 and 3 will be equal. The reason is alternate interior angle. Similarly, we can say angle 2 is equal to angle 4. The same reason we have for both. These both pairs are alternate interior angles. Right? So we have two angles equal and the included side as equal in both the triangles. What do we see from it? That according to angle side angle ASA congruency rule, we can apply in this and prove that the triangle ABC is congruent to triangle ADC. Right? And what do we mean by congruent triangle? That they overlap each other. That means their corresponding parts are going to be equal. So what can you say about the side AB and DC? You know, when we fold the triangles along the side AC, so AC will be the base for both of them. AB is going to come upon DC and BC will overlap side AD. So what we can say, that we can say from this AB is equal to DC and AD is equal to BC. And the reason is CPCT, that is corresponding parts of congruent triangles. So that means we have proved the pairs of opposite sides are in equal length. The pairs of opposite side are of equal length. This is what we had to show in the theorem or the property, and that is what we have proved, that the opposite side in a parallelogram will be of equal length always. So we now have two things about the parallelogram. Okay, so it will be a quadrilateral having four sides. It will be a polygon having four sides. Then the opposite sides or pair of opposite sides are parallel to each other. right? We have two parallel pairs. That means AB here is parallel to DC as well as BC is parallel to AD. Right. The second thing that we have proved here is we have proved the opposite sides are going to be equal in length. Clear? Let us now do one question based on this property. So here comes the question, and it says find the perimeter of this parallelogram PQRS. Here PQRS is a parallelogram as given to us, and two of its adjacent sides are given, PQ and QR, right? So what about the side PS? Just now we have proved one property, that the opposite sides in a parallelogram will be of equal length. So if QR is 7 cm, what about SP or PS we say? It will also be 7 cm. Right, so these two will be equal. If PQ is 12 cm, what will be the measurement of SR? Just think carefully. This is the opposite side of PQ, and because it is a parallelogram, it will be equal. So if this is 12, SR will also be 12 cm. And what do we mean by perimeter? It is the measurement of the boundary, right? That means we are going to add these four sides. So you will just write that perimeter of PQRS will be equal to 12 cm plus 7 cm plus 12 cm plus 7 cm, or before this we can also write PQ plus QR plus RS plus SP, right? And we have just placed in the values of it. 12 plus 7 will be 19 cm plus again 12 plus 7 is 19 cm. That gives the answer as 38 cm. The unit of perimeter will be centimeter, same as the length of the sides given. Clear? Because perimeter is also the length only, right? The length of or the measurement of the boundary. So this is how we are going to use the property of parallelogram, that the opposite sides are equal, to solve this question. Clear? Now we are going to discuss one more property of parallelogram, and here is the property, that it says the opposite angles of a parallelogram are of equal measure. So I think you might think that you're very close to the answer, because the same way we have proved for the previous property, we are going to prove this. Let us just revisit the same thing. So what we did in the last one, we have drawn one parallelogram and named it as, suppose, A, B, C and D, and then we are going to join A to C. You can join either A to C or we can join B to D. Any one diagonal we can draw. We have then marked the angle as 1, 2, 3 and 4. Right, and after that what we did is, in triangle ABC and triangle ADC, so what we see in these two triangles, that AC is equal to AC being the common side in both of them. The next thing is, angle 1 is equal to angle 3, angle 2 is equal to angle 4. Reason has already been explained in the previous property. They are alternate interior angles. Right? So we have one included side and two of the angles as equal. So according to angle side angle rule, the triangle ABC is congruent to triangle ADC. Because these two are equal, their corresponding parts are going to be equal. So we can say that angle B will be equal to angle D. That means the opposite angles are equal. Similarly, if we join B to C, we will get that angle A is equal to angle C. You can just prove in the similar way. We can join B to D and we'll get angle A and C as also equal. So what result that we have reached on to? The result is that, or the conclusion is that, the opposite angles in the parallelogram are of equal measure. Clear? So there can be many questions made on the same property, and we can use the property of sides being equal, angles being equal to prove or to solve the questions. Right? Let us practice one question based on this. So here is the question, and it says that in this figure BEST, BEST is a parallelogram. So looking that it is a parallelogram, we till now know two properties, and one is the basic one that the opposite sides are parallel to each other, opposite sides are equal to each other, and the last one that we just proved is opposite angles are equal. Here we have to find the values of x, y and z. So similarly, so thinking carefully just to see if angle B is equal to 100 degree, what about angle X? Angle X is opposite to this 100 degree, right? So we can directly say that the measurement of angle S, or which is shown in the figure as X, is equal to 100 degrees. What is the reason behind it? The reason is that these are the opposite angles. So we're going to write the reason also in the bracket, opposite angles of a parallelogram. So angle X is, or angle S is also 100 degrees. Now we are concerned about angle Y and angle Z. So just looking carefully, if I extend this side BT also like this. Okay, so we see that this side BT and this side SE, they are parallel sides, and this BZ is working as a transversal. So what we can say? We can say that Y angle Y will be. So we can say that Y measurement will also be 100 degrees, and the reason for it is alternate anterior angles. The last part that I am left with is finding out angle Z. How do we find angle Z? We know that Y plus Z is forming a linear pair, so their sum is equal to 130 degrees. Reason is linear pair. Right, so using this reason, now we know Y is equal to 100 degrees. So what will be Z equal to? It will be 180 degrees minus Y, which is 100 degrees. So Z is going to be 80 degrees. So the measurement of Z we have calculated as 80 degrees. The measurement of Y is equal to 100 degrees. So this is how we have used the property that the opposite angles are equal. Then we have used the parallelism, right, and the transversal between these two parallel lines BT and SE to find out angle Y. So this is how what we are doing is using the properties of parallelograms to solve the questions. Fine. Let us see another thing. Here comes another property. So this is the adjacent sides in a parallelogram are supplementary. What do we mean by supplementary angles? Supplementary angles are those whose sum is equal to 180 degrees. Right, and what do we mean by adjacent angles? As we have already discussed in elements of our parallelograms. So let us draw one parallelogram. Let the name be A, B, C and D. Now in this we have to tell that the adjacent angles, or we have to prove that the adjacent angles in a parallelogram are supplementary. How do we prove it? Now we have already discussed that the sum of interior angles of a quadrilateral is always going to be 360 degrees. So let us use that. We know that angle A plus angle B plus angle C plus angle D is going to be 360 degrees. Now what about angle A? Angle A is equal to angle C and angle B is equal to angle D. Why? Because these are opposite angles of the parallelogram. Right? So angle A plus angle B plus, instead of angle C, we are going to replace it with angle A. And for angle D, the replacement will be with angle B, and it is equal to 360 degrees. Angle A plus angle A gives us 2 times of angle A, plus angle B gives us 2 times of angle B, and it is going to be 360 degrees. So taking 2 common, we get angle A plus angle B is equal to 360 degrees. If we divide both the sides with the 2, we get angle A plus angle B is equal to 180 degrees. So we have proved the adjacent angle A and angle B are adjacent, and their sum is going to be 180 degrees. That means they are supplementary angles. Similarly, instead of angle A and B, we could have replaced angle C and D with angle A or B, or we could replace A and B with angle C and D. So we would have got the answer as angle C plus angle D as 180 degrees. So we can do it anyway, right? The purpose is to show that the adjacent angles in a parallelogram are supplementary. So this is again one of the property of the parallelogram. So till now what we have done, we know that the opposite pairs or the opposite sides are parallel to each other, opposite sides are equal to each other. The next property that we discussed is opposite angles are equal to each other. Just now we have discussed that the adjacent angles are supplementary. Clear? Let us go to the next thing. Here is one question, and by using the previous property we have to find all the angles. We have been provided with one angle. So it says in a parallelogram ring, RING is the name given to the parallelogram in this figure, and the measurement of angle R is 70 degrees. We have to find out all the other angles. So looking carefully, we know that opposite angles are going to be equal. If measurement of angle R is 70 degree, then it will be equal to measurement of angle N. That means measurement of angle N will also be 70 degrees. Reason is opposite angle of the parallelograms, right? So I'm writing opposite angles here. Now the next thing that we know is R and I are adjacent angles, and just now we have proved that the adjacent angles of a parallelogram are supplementary. So we can write that angle R plus angle I is equal to 180 degrees, and angle I will be equal to 180 degrees minus angle R. What is the measurement of angle R? We know it is given as 70 degrees. So we get angle I as equal to 110 degrees. So here I am writing 110 degrees, the measurement of angle I. Then what about angle G? Angle G will also be equal to 110 degrees, being the opposite angle of I, right? So I'll write just opposite angle to I. So this is how we have found out all the four angles. You can add them and can satisfy the property that the sum is 360 degrees, right? So knowing the one angle, we can find all the other angles using the properties of parallelogram. Clear? So now we are going to discuss the next property, that is the diagonals of a parallelogram bisect each other. So let us draw one parallelogram. Let this be our parallelogram, and let us name it as A, B, C and D. Now there are two diagonals AC and BD. Let us draw them. Join A to C and join B to D. Right, now what we are going to do is, after joining the diagonals, we'll mark the intersection point as O. Now we'll take triangle DOC and triangle AOB. What do we see in these two triangles? We see that AB is equal to DC. Why? Because these are the opposite sides of the parallelogram. Yes, we have just proved the property. Now the second thing that we can use for making these two triangles as congruent is angle 1. This can be equated to this angle 2. Angle 1 equal to angle 2. Why? What is the reason? We have already used this, that this is alternate interior angles between the sides DC and AB, because we know that DC and AB are parallel to. Now we'll write angle 3, this one, angle 3 and angle 4. What is the relationship? That they're also going to be equal with the same reason as alternate interior angles. Right? Now two of the angles and the included side is equal. So using which rule? Using angle side angle rule, we prove that triangle DOC is congruent to triangle AOB. Right? Now these two triangles are congruent. What about their corresponding parts? They're definitely going to be equal. So we can say that OD is equal to OB and OA is equal to OC. These are using CPCT, that is corresponding parts of congruent triangles. So what we have seen, that this OA is equal to this OC, right, and this OD is equal to this OB. Clear? So we have proved that the diagonals bisect each other in the parallelogram. Here is a question for practice. Just to see, it says in figure help HELP is a parallelogram. All the lengths are given in centimeter. So OE is given as 4. This OE is given as 4 centimeter. HL is 5 more than PE. So HL is equal to 5 more than. So I'm writing plus 5 more than what? PE. So HL is equal to PE plus 5. Right? Now how do we find it? If we know that OA is equal to 4 centimeter, then what about OP? Think carefully. Just now we have proved that the diagonals bisect each other. That means the diagonal PE is bisecting this diagonal HL. So can we find out OP? Yes, definitely. OP will be equal to OE. Right? Now because OE is 4 centimeter, OP will also be 4 centimeter, and we know that PE is equal to OP plus OE. That means it is 4 plus 4, that gives us 8 centimeter. So what is the length of one diagonal, that is PE? It is 8 centimeter. Right? Now we have to find out HL, which is the another diagonal, and it is given in the question that HL is 5 more than PE. So 5 more than PE, that means PE is 8 centimeter plus 5, that gives us 13 centimeter. So we know that HL is 13 centimeter. Find out OH. This is the final question that we have to reach to OH measurement. So how to find OH? OH will be half of HL, right? Because the diagonals bisect each other. So half of 13 gives us 6.5 centimeter. Right? So this is how we can find out all this OL, OH, OE, OP, knowing just one of the measurement out of the 4. Clear? So we have found out both the diagonals as well as the parts that they have bisected. Right? So this is using the properties of parallelogram. In the next video, we're going to practice a lot of questions based on these properties, and we're going to solve questions in a very easy manner. That's all for today.